Hey, it's Toby for XP Dojo, and today we're going to look at refactoring. Now, refactoring is a term that's often misused, so today we're going to look at what refactoring really means. So we'll go through some examples. We'll have a look at things like extracting a method, moving methods, replacing noisy temporary variables, and my favourite, deleting code. Let's start with what is refactoring. Let me tell you what it isn't first. And this is the one big point that I want you to take away. Refactoring is not adding new behaviour. What refactoring is all about is preserving behaviour. It's about changing the internal structure of a program without changing the external behaviour of that program. If you're coding and not preserving the existing behaviour, you're not refactoring, you're building something new. That begs the question, if all you're doing is changing the internal structure, why bother? If it's not broken, why fix it? Well, we don't refactor for the sake of it. We're trying to improve the code to make it easier to work with or understand. This could be because it's difficult to read, maintain, test, or difficult to add new functionality. When we shuffle things around to make the code easier to work with, we're investing the time now because we're expecting it to pay off later. So for example, if the cost of change to implement a new feature without refactoring is A, the cost of refactoring plus the cost of change to implement the same feature should in theory be less than A. So when do we refactor? All the time. It's an XP principle that if something is worth doing, do it to the extreme. It's about time we take a look at some examples. Let me introduce the example program we'll be working with. We're starting with a video store application. It's been written in Java, and I'm going to show you how refactoring before introducing new features saves time and can improve design. So the program calculates rental fees for a customer. There's the usual complexities, the fees vary by the type of movie rented, and there's a loyalty scheme for frequent renters. Some of the classes we'll be looking at include a class to represent the customer, a class to represent the rental, and one for the movie. Let's jump straight into the customer class. As you can see, the customer has a name, a list of rentals, and a statement method that does the heavy lifting. That's the bit that calculates and prints the customer fees. What's your first impression of this class? It seems quite noisy to me. It's very dense and it does a lot, especially that statement method. The nasty switch block isn't good. So what happens if we get a new requirement? Let's say to produce a different statement for the customer, this time as HTML. We're left with the choice of duplicating the existing statement method or somehow reworking it. We're always trying not to repeat ourselves in code, so let's have a look at how we would go about reworking the method and make it easier for ourselves to add a HTML statement. Before we can rework the method or refactor it, we need to be sure that we won't be changing the existing behaviour as we do so. And the best way to do that is to write some tests. Luckily, we already have some tests, so I can just run those now. They make some basic assertions against the existing behaviour. We don't need to worry too much about the details for now. If we run those, they go green. They're here to make sure that we don't change the externally observable behaviour as we go. They're our safety net. We can now look at our options for chopping up that rather unwieldy customer class. The first thing we're going to do is identify chunks that we can pull out into their own smaller methods. If we do this right, we can hopefully reuse those smaller methods later on. We'll be using the extract method refactoring to do this. This piece of code looks like a prime candidate. It's all related to calculating the fees, but there's a lot of it. It'd be good if we could chop that up and move it to its own method. Let's create that method and call it getAmount. Done. You can see that the whole block of code has moved to a new method here. It's the same implementation, we've just physically moved it to its own method at the bottom of the class. We call it from a single place here, and we've started to shrink the statement method. All that's left to do now is run our tests and make sure we haven't inadvertently broken anything. Great. Our new method calculates the charges for the rental, but we've called it getAmount. That's a little confusing, so let's clear that up by renaming the method. We'll rename that from getAmount to getChargeForRental. We haven't changed the behaviour, we've just changed the name to clarify our intent. Everything still passes. Great. If we look more closely at that method, you might notice it uses information from the rental class, but nothing from the customer class. So why is it on the customer class? It makes more sense for the rental to work out that charge. So we can do a refactoring called move method to quickly move this method from the current customer class onto the rental class. It's as simple as that. We can see here that we've moved from calling the method and passing the rental as a parameter to calling a method on the rental instance. And if we have a look at the rental class, the implementation has moved verbatim, but now it can use data directly from the class. This gives us better encapsulation for the rental class. We run the test to see if we haven't broken anything. Everything still passes, that's great. The next thing you might notice is that this amount variable is now redundant. It's used in two places to construct the statement. And we can use a refactoring called replace temp with query here, which is effectively inlining the occurrences of that temporary variable with a call to the method. So we now query the method for the value in those two places, rather than store the value temporarily. Again, we run our test to see if everything goes through okay. We haven't broken the existing behavior, so we're good to go. The next step is to move the calculation of the frequent renter points. It's this piece of code here. We'll use the extract method refactoring again to isolate the calculation. So I'll call this method calculate frequent renter points, and I'll go ahead and create that. You can see here that the IDE is asking me to initialize the return variable, which whilst I'm here, I'll rename to something a bit more concise. That's it. Let's run our tests. We've missed something. It's no longer totaling rental fees correctly. If I look back at the code, I can see that I forgot the plus operator. Let's run those tests again. This time they pass, great. Just like before, this new method uses data from the rental class, not the customer class. So we'll repeat our previous refactoring and move this onto our rental class. This line is now calling the new method, just like before. Things are looking much neater now, and if we jump into the new method on rental, we can clean things up even more. We can simplify the implementation here by dropping the temporary variable. There's no need to keep it when we can short-circuit things with multiple return statements. For example, if this condition is met, we can return 2. In all other cases, return 1. The points variable is no longer used, so we can get rid of it. The comments seem less useful now too. We know what the method is doing by looking at its name and its simplified implementation, so we can just get rid of those too. It may not feel like it, but delete is a valid refactoring in its own right. Let's run the tests. Green. Okay, let's jump back to the customer class for a second. There's still lots more we can do here, but you can begin to see how we've reduced its overall size. It's much less dense and easier to see what's going on. That should mean it's easier to maintain and easier for us to add in our new HTML statement. Let's fast forward a little bit and see what the class would look like after performing one or two more refactorings along the lines of those we've already seen. Okay, so I've applied the same refactorings we've already seen to move out the remaining calculations. This leaves us with more of a template for printing statements. I've used that template to create a new HTML version. Both the original print method and the new HTML version call our newly refactored code. When it came to adding the new feature, I could do it with minimal effort, and thanks to the refactoring, I've done it without duplication. In summary then, we've looked at what refactoring is and what it isn't. Remember my big point? That add-in behavior isn't refactoring. We looked at some basic techniques, building blocks, which help you to decompose problems with extract method, move tools better design with move methods, be clearer with rename, and remove clutter with inline and delete. We also saw that tests are essential to keep us honest. If we hadn't seen that failing test, we would have missed a serious bug. That's it for now. Go get the source code and have some fun with it.